Good morning. My name is Uma Maheshwari. I am here to tell about the VLSI test design subject, the topic of VLSI testing and the need for testing. Here in this case, the need for testing, that is mostly results from decreasing the feature size. That is, the feature size comes under like dimensions from 10 to micrometer to 10 nanometer for transistors and interconnecting the wires. Operating the frequencies have increased from 100 kilohertz to several gigahertz. Decreasing the feature size increases the probability of defects during the manufacturing process. A single faculty transistor or wire which results in a faculty IC. Here the testing required to guarantee these fault-free products. And the next one is why this is how we are just going for this testing. So here the rule of 10, that is the cost to detect the faculty IC increases by n order of magnitude as we move from device to PCB and to the system and to field operation. Here the testing performed at all these levels. Here the testing also used during manufacturing to improve the yield. Here the failure mode analysis, that is FMA, the field operation to ensure the fault-free system operation and which initiates the repairs when faults are detected. Here the need of testing is, testing typically consists of applying set 2 test stimuli to inputs of circuit under test CUT and analyzing the output responses. If it is correct, that is the circuit under test assumed to be faculty, and if it is correct or if it is pass, the cut assumed to be a fault free one. Here from this input test, from this simulation, and here you will be giving to this output to the circuit under test, and the output from this circuit under test gives to the output response, which is also called as an analysis. That is, it will give the pass or fail, that is it will give the result of this one. And the next one is design verification targets and design errors. Here in this case the design specification gives to the design and then fabrication and then packing, quality assurance. Here the design verification gives the verification process to the design, and the wafer test fabrication, it gets the wafer test, and this packaging is taken from the package test. Here and this one, the quality assurance is getting the thing from the final testing. Here the design verification targets design errors, the corrections made prior to the fabrication and which remaining the test targets manufacturing defects. A defect is a flaw or physical imperfection that can lead to the fault. Here the assessment questions based on this video I have taken is, design this Moore's law. The Moore's law is a very important one, and what is the need of testing here, and explain in blocks in testing. The explain in blocks in testing is like this is the, I told you like before itself, like testing this input and it goes to the circuit under test. This input testing is from 1 to n, that is it can go to 1 to n. So this is not a single input which is single output which comes from this input test and goes to the circuit under test. This is a multiple input to the circuit under test, and the output we have taken is from the circuit under test is the same, like not only the only one output we will be taking and multiple output. How many inputs we have given, those output will be comes from this CUI, that is circuit under test. From 1 to n means here we will be mentioning it as 1 to n. The output response is an analysis process. So from this analysis process we can get the output of whether it is 0 or 1 or it is pass or fail. So this block you have to draw whether we if the question is from need of testing. and also the design testing importance, that is what for this design testing is done. So you have to write this one. Thank you.